Good evening to all. Welcome to my seminar presentation on the topic Advancements in Flexible Electronics in Healthcare. I am Novin Thomas Major from S7ECB and my guide is Professor Nidayam Biju from the Department of EZ SSC Parai. So, looking upon to the contents of the seminar, first we have introduction, then history, flexible electronics, advantages and disadvantages of flexible electronics, applications, flexible electronics in healthcare, integrated flexible sensors, then flexible electronics for pulse and BP monitoring, flexible electronics for ECG monitoring, flexible electronics for echocardiogram monitoring, manufacturing of flexible electronics, materials used for manufacturing, future scope, market growth, leading manufacturers of flexible electronics, restraints and challenges of flexible electronics, conclusion, and then references. So, looking upon to the introduction of the flexible electronics, flexible electronics are integrated with stretchable or bendable structures and various microsensors that monitor the temperature, pressure, sweat, bioelectricity, body hydration, etc., and have a wide range of applications in human healthcare sector. The science underlying these technologies draws from many research areas such as material science and structural mechanics to efficiently and accurately monitor various signals. In this seminar, we make a classification and comb to the designs, materials, structures, and functions of numerous flexible electronics for signal monitoring in the human healthcare sector. Some perspectives in this field are discussed in the concluding remarks. So, looking upon to the history of the flexible electronics from 1903, Dr. Ken Galileo have a patent on the flex circuits, uh, also known as flexible electronics. Then 1947, the printed circuit techniques, a book by Brunetti and Courtois, have given a small impact to the uh, for the idea on flexible electronics. And then 1915's Photo Circuits Corporation, a company, has designed uh, has planned to design a flexible electronics device from 1970 to 1990. The organic electronics era changed the face of flexible electronics. The organic thin film electronic devices have developed. It is a flexible devices that made made up of organic substances. Mm, then flexible transistors and flexible LED devices has been developed. The early applications of flexible devices has started from 1990s to 20s. In that time, the thin film transducers were developed. From 2000 to 2010, inorganic based flexible devices has been developed. Flexible printed electronics and modified thin film transducers from inorganic compounds has been developed. Uh, some of the flexible electronics has been developed in that periods are paper-like flexible display in 2001, artificial electronic skin in 2004, pressure and temperature distribution sensors using flexible components has been developed in 2005. Then in 2010, e-skin devices has been developed. Uh, and due to the development of e-skin devices from 2010 to 2023, a huge change of flexible electronics its face has been changed. The e-screen devices has impacted on on the idea of developmenting of bendable and foldable displays, wearable electronics for healthcare applications, and hybrid integrated flexible devices for many applications like healthcare, automations, etc. has been automobile has been developed, and now the research and development for potential future applications are ongoing. So looking upon to the flexible electronics, flexible electronics are electronic devices that can be bent, rolled, or folded without losing functionality. Uh, they are built on flexible substrates, usually plastic, metal foil, paper, or flex glasses. And the substance can be a polymer, PEEK, or transparent conductive polyester material. Flexible electronics enable new product patterns that aren't possible with the conventional semiconductors and glass substrates. They are made up of at least four parts, including electronic components, flexible substrates, cross-linked conductors, sealing layers. Also, these parts are combined together using a adhesive layer, which is strong, flexible, and chemical stable. Researchers and researchers and industries are working to create electronic devices that can be flex, roll, or bent. So, looking upon the advantages of flexible electronics, lightweight design, improved portability, energy efficiency, ability to withstand mechanical stress, low cost manufacturing, inexpensive flexible substrates, ability to make previously impossible designs and technologies possible. And its disadvantages are higher initial cost, more likely to get damaged during handling. Changes and repairs are difficult. Integration of components could be a challenge. Precision machines are required for the manufacturing of flexible electronics. So, applications of flexible electronics are uh, flexible electronics can bend to any shape during its production or as a part of its production. Final design of the product. These flexible printer electronics enable groundbreaking new applications. For example, comfortable wearable devices, electronic skin patches that revolutionize healthcare. So, flexible electronics can be used in healthcare, including wearable health monitoring devices and medical implants. For example, a patch sensor that can be used for detect blood glucose concentration. And also, flexible electronics can be used in other industries such as consumer electronics, industry technology, automotive technology, aerospace technology, and one for also soft robotics and development of integrated flexible sensors. So other applications are consumer electronics, industry technology, automotive technology, aerospace technology, foldable displays, military electronic devices, flexible integrated sensors, energy management and mobile devices, flexible electronic components, wireless displays, etc. This figure shows different types of flexible electronic devices like antenna, solar panel, sensors, flexible displays, flexible battery, flexible capacitors, and flexible inductors. So, flexible electronics in healthcare. Flexible electronics are used in healthcare to monitor uh, health and identify disease indicators. This can be used to create wearable or implantable devices that can fit into curved surfaces such as skin and organs. Flexible electronics can be wireless, miniaturized, and multifunctional. This can be used for identify cardiovascular disease indicators, detect blood glucose concentration, etc. Flexible electronics provide an excellent platform for personalized healthcare that can be easily operated by patients. They allow for continuous, real-time, and comfortable monitoring of blood pressure, ECG, echocardiogram, and epicardium. These devices offer clinically relevant indicators for both preventive healthcare and disease diagnosis. Uh, so, integrated flexible sensors. Integrated flexible sensors are sensors that integrated with the sensors that can detect tiny physiological signals and have been used to monitor human health. A patch sensor that can be used to detect blood glucose concentration is an example for an integrated flexible sensor. It is composed of two parts, a flexible paper battery patch and a biosensor patch. Uh, Flexible sensors are used for detecting blood pressure and respiratory rates in real time. So, flexible electronics for pulse and BP monitoring. Uh, they are mainly a flexible strain or pressure sensor. They are used to track pulse waves in real time for health monitoring and assessment. Pulse wave contains health-related physiologic signals like heart rate, respiratory rhythm, and blood pressure. Uh, a flexible sensor can be mounted on forearm, boot, and wrist to evaluate cardiovascular status. The development of wearable devices has placed great demands on the accuracy and consistency of sensors. However, research and development of wearable continuous blood pressure monitoring devices still face great challenges. Uh, then looking upon to the different flexible electronic sensor for pulse and blood BP monitoring. Uh, these are the some of the examples of flexible electronic devices for pulse and BP monitoring. This is the principle of a flexible mechanical sensor for pulse and BP monitoring. This is a silk micro patterned like flexible piezoresistive sensor for wrist pulse monitoring. It is micro hair flexible capacity sensor, then sandwich flexible piezoelectric sensor, then multi-level microstructured flexible piezoelectric sensor, then kirigami inspired flexible triboelectric sensor, woven sensor for continuous beam measurement of fingertip, burst, ear, and angle. Here, flexible sensor based on soft magnetoelastic fibers for underwater artery pressure, pulse. Uh, then flexible electronics for ECG monitoring. ECG is a pivotal uh, diagnostic examination that measures and records cardiac electric impulses via an electrode pair mounted on the chest. ECG contains tiny adhesive electrodes attached to the limbs and chest, which are subsequently connected to the ECG recording apparatus. In contrast to conventional ECG methodologies that constrain the patient's movement, the flexible electrodes are able to adapt to complex skin surfaces and thus provide sufficient comfort. The integrated system, coupled with the electrodes, has independent ability to perceive and process the data of diagnosis, liberating people from the traditional heavy equipment and leaving them free to continue their daily life during measurement. Moreover, it is cost effective and disposable. Until now, flexible electronics for ECG monitoring are primarily flexible mechanical electronics, which are further divided into uh, epidermal, uh, epidermal and implantable electrodes based on their application scenarios. Uh, these are the different flexible electrodes for ECG monitoring. Hydrogel interface between human skin and wearable bioelectronics. Hydrogel interpenetrated by chitosan and gelatin can eliminate dynamic noise under 30 Hz and filter biophysiological signals. Multifunctional tendon mimic, mimetic hydrogen without standing mechanics and functionality by anisotropically interpreting nanofiber composites. Then highly air permeable, water drainable, and reusable patch bio inspired by tree frogs and octopi. Then active multi-electrode array coated by soft poly that can simultaneously achieve non uh, thromo, thrombogenicity, structurality, and stability. Then epicardial bioelectronic patch that can perform spatiotemporal mapping for electrophysical activity, strain, and temperature sensing. So, flexible electronics for echocardiogram monitoring. Echocardiography has evolved into a customary practice for diagnosing, managing, and monitoring individuals with suspected or confirmed cardiovascular disorders. Electrocardiograms not only generated ultrasound uh, depi- depictions of cardiac structures but also facilitate precise evaluation of blood circulation in the heart through Doppler electrocardiography, employing pulse wave and continuous wave and Doppler techniques. Flexible electronics that are available as wearable, implantable, or highly integrated configuration enables continuous and real-time monitoring of echocardiography data, opening a new way to circumvent the convolutional medical workflow. Or there are two types of flexible electronics for echocardiogram monitoring. That is, first bioadhesive ultrasonic imager. It is for a long-term continuous imaging of diverse organs. Uh, a thin and rigid ultrasound probe consisting of high density and high performance piezoelectric element is adhered to the skin via a bioadhesive coupling made of a soft, tough, and anti-hydrating hydrogen elastomer hybrid. Uh, it continuously continuous imaging shows the dynamics of the stomach before and after drinking. Color flow imaging of a carotid artery and the diameter of the carotid artery is shown in the figure here. Uh, then wearable cardiac ultrasound imager. Uh, the first figure that figure B, the first figure of section B has showing the flexible probe consists of piezoelectric transducer arrays, liquid metal composite electrodes, and a trivalent copolymer electrode persuasion. Photography from several views are shown in the second figure of section B. Uh, then manufacturing of flexible electronics. A variety of methods such as printing, lamination, and deposition are utilized to produce flexible electronics. These methods enable the development of lightweight, thin, and extremely flexible electronic parts like sensors, displays, and batteries. The creation of flexible electronics necessitates specialized equipment, expertise, and use various materials such as conductive inks, polymers, and metals. With the growing demand of flexible electronics, the requirement for efficient and cost-effective manufacturing techniques is also increasing. So, uh, printing technology is a manufacturing technology for the manufacturing of flexible electronics. Printing technologies are widely used for manufacturing flexible electronics due to their cost effectiveness and scalability. These technologies includes the following: inkjet printing. The technology uses a printer head to spray ink onto a substrate and create patterns. It is often used for printing conductive inks on flexible substrates. Then screen printing. This technology uses a mesh screen to transfer ink onto a substrate. It is often used for printing large area patterns on flexible substrates. Flexographic printing. This technology uses a flexible printing plate to transfer ink onto a substrate. It is often used for printing high resolution patterns on flexible substrate. 3D printing. This technology holds promise for fabricating flexible electronics with complex geometries. Various 3D printing technologies have been proposed for creating flexible electronics, from planar structures to complex steric geometries. Deposition technologies. Uh, they are another set of technology used for flexible electronics manufacturing. These technologies involve the deposition of thin films of materials onto a substrate to create electronic devices. The most commonly used deposition technologies include physical vapor deposition. This technology involves the deposition of material onto a substrate through the process of evaporation or sputtering. PVD is a commonly used for deposition metals and metal oxide into flexible substrates. Chemical vapor deposition. This technology involves the deposition of materials onto a substrate through the process of chemical reaction. CVD is commonly used for depositing thin films of organic materials onto flexible substrates. Atomic layer deposition. This technology involves the deposition of materials onto substrates through the process of layer by layer deposition. ALD is commonly used for deposition thin films of dielectric materials on flexible substrates. Then template methods. Template method is a commonly used high throughput patterning technology. The working principle of that is that polymer materials replicate the required patterns from master molds which need to be designed in advance. Due to the considerable flexibility, mild operating condition, as well as the accurate controllability over morphology, size, and structures, template method has been widely adopted for the fabrication of flexible electronics. Materials used for manufacturing flexible electronics. Conductive materials, silver nanowires, carbon nanotubes, conductive polymers. Substrate materials like polyamide, polyester, and polyethylene terephthalate. Future scope. Flexible electronics have revolutionized the design of devices, allowing for form factors that were previously unimaginable. This unique capability gives them an advantage in the field of healthcare. Flexible and printed electronics offer advantages such as integration, robustness, customized slim designs, flexibility, and lightweight construction. As our society ages and there is a growing interest in monitoring parameters to optimize training or predict long-term health issues, there is a need for to use and comfortable devices. Flexible and printer alternatives will play a role in enabling the development of products and applications. Then market growth. The global flexible electronics market is expected to reach 87.21 dollars dollar billion by 2024. The market is projected to grow at a compound annual growth rate of 19.1% from 2022 to 2020, 2030. The increasing Use of 3D technology in healthcare is a major trend in the global flexible electronics market. Flexible electronics have gained popularity with the growing numbers of applications, including wearables. So the leading manufacturers of flexible electronics are Samsung Electronics, Bluespark Technologies, Symbet Corporation, Panasonic, Infocell Soft Battery, Imbred Energy Incorporated, LG Electronics, Palo Alto Research Center Incorporated. So the restraints and challenges of flexible electronics are high cost of investment in flexible electronics, complexity of flexible electronics, obvious motion noise, reliability, slow dynamics, and scalability. So the conclusion, flexible electronics have the potential to revolutionize the healthcare industry by enabling patient-centered approaches to diagnosis, monitoring, and treatment. However, many of the capabilities and device prototypes in this field are still in their stages of development. They have mainly have been tested in laboratories or under conditions without considering world clinical environment. This seminar sets itself apart from ones by not focusing on concepts, materials, functions, designs, or fabrication, but also aiming to captivate researchers from related fields and spark their curiosity about practical clinical applications. So these are the reference that used for the seminar presentation. Thank you and have a nice day.